Today we're going to be learning about finding side lengths using trig ratios. Our objective is that we will be able to use trig ratios to solve for side lengths in right triangles. Alright, probably one of the most important things. Again, we talked about this last class. Your calculator must be in degree mode. Super, super important. So let's look at my calculator and review how to do that. Alright, degree mode, we push the mode button. Go down to where it says radian, go over to degree, and push enter. Now degree is darkened and we know that we are in degree mode. Let's also review our trig ratios. If we were looking at ratios for angle x, straight across from that is our opposite side. Across from our right angle is our hypotenuse. And that leaves our other side as our adjacent. So if we want to find sine of x, remember, sine is equal to opposite over hypotenuse. So opposite is 3. So we get 3 over the hypotenuse of 5. When we see cosine, we think of ca. Cosine equals adjacent over hypotenuse. The adjacent is 4 over a hypotenuse of 5. For tangent, that's our TOA. T equals opposite over adjacent. Opposite has a length of 3. Adjacent has a length of 4. Now remember, even if we're using the same triangle but we're using a different angle, that's going to change things up a little bit. If we're at angle Y, then our side with 4 is our opposite. 5 is our hypotenuse still because it's across from the right angle, and that makes 3 our adjacent side. So sine of y, opposite over hypotenuse, is 4 over 5. Cosine is adjacent over hypotenuse, 3 over 5. And our tangent is opposite of 4 over the adjacent of 3. So let's see how we can use these ratios to help us find side lengths. Alright, so if we want to solve for x in the following triangle, first we need to choose one acute angle and label the sides. Well, I'm going to choose the acute angle that's labeled here. And if we want to label our sides across from that, that's our opposite side. Across from the right angle is our hypotenuse, which leaves our other side as our adjacent. So the information that we know that our adjacent side is 4, and we know our hypotenuse is x. So since we have a and h, we're going to want to use cosine. So the trig equation would be cosine of 78 degrees is equal to the adjacent side of 4 over the hypotenuse of x. So now we need to solve this equation, and we're going to round our solution to the nearest hundredth. Who remembers how many decimal places hundredth is? Hundredth means 2 decimal places. So we'll need to remember that at the end. So I'm going to copy down our equation. Cosine of 78 equals 4 over x. So we need to get x by itself, and let's get it out of the denominator. So I'm going to multiply both sides by x. So I have x times cosine of 78 equals these x's would have canceled each other out. So I'd just be left with 4. But unfortunately, x is still not by itself. We need to divide both sides by cosine of 78. Those would cancel out. So we're left with x equals cosine, 4 over cosine of 78. Now we want to know what this actually equals. So we're going to put it in our calculator. 4 divided by cosine of 78. So 19 point, and remember it said round to the nearest hundredth, which is 2 decimal places. So 19.2, 19.23, but we need to look at the third number to let us know whether or not we need to round up the 3. So 2.4, because the 8 would make the 3 round up. Now, what is another equation that we could use? Erase my markings on my picture. See our other options. We know that the angles in a triangle add up to 180. And if this corner is 90 of them, then the other two together make 90. So since this one's 78, that leaves 12 degrees to be this small angle up here. And we could have used that and said from this angle here over, this would be the opposite side. This would be the hypotenuse. And this would be the adjacent side. Therefore, we know the opposite side and the hypotenuse. So we could have used sine of 12 equals 4 over x. Then again, we would multiply to get the x out of the denominator. times sine of 12 equals, these x's would cancel out, so it equals 4. And then to get x completely by itself, we would divide by sine of 12, sine of 12. So we get that x equals 4 over sine of 12. So x equals, let's check it on our calculator, 4 divided by the sine of 12. Came out to be the exact same thing. My recommendation, though, is to always use the angle you're given. This way you don't accidentally subtract wrong and mess up your work. But this is also a good way to check your work when you're done. So let's practice a couple more. We're going to find the missing side lengths in each right triangle using trigonometry, and we're going to round to the nearest tenth. How many decimal places is a tenth? That's 1 decimal place. So the first thing we needed to do was choose an acute angle and label the sides. So we know 68 degrees here, that's going to be our angle. Across from that is our opposite. Across from the right angle is the hypotenuse, and the other sides are adjacent. So we know opposite and we know adjacent. So which ratio should we choose? That's right, we should choose tangent. Tangent of 68 equals x over 12. Opposite over adjacent. We need to get the 12 out of the denominator, so we multiply both sides by 12. We get that 12 times tangent 68 equals, the 12s would cancel out, equals x. Well, look, x is by itself, so that means head to the calculator. X equals, in our calculator, 12 times tangent of 68. We're rounding to a tenth, so that's 1 decimal place, so 29.7. Let's look at another one. Which angle are we going to choose? We're going to choose the 58 because we know it. Across from that is our opposite. Across from the right angle is our hypotenuse. And the other sides are adjacent. What do we know? We know opposite and hypotenuse. O and H means we're going to use sine. So sine of 58 equals 16 over x. Get the x out of the denominator. X times sine of 58 equals 16 because the x's would cancel out. Divide by sine of 58. Divide by sine of 58. X equals 16 over sine of 58. X is by itself now, so we're going to type it in our calculator. 16 divided by the sine of 58. And our directions at the top said to round to the nearest tenth, so 1 decimal place. We need to look at the one before that. The 6 would make the 8 round up to a 9, so 18.9. And for our last example, this one has two variables. We're going to find both of them. So we're going to choose this angle because that's the angle we're given. Across from that is opposite. Across from the right angle is hypotenuse, which leaves our other side to be adjacent. So let's look for x first, just because it comes first in the alphabet. We know we want to use the adjacent side because that's one of the things we know. Then we're also going to use the hypotenuse because that's the side we're looking for. So we have sine of 40 equals 8 over x. Oh, I'm sorry, not sine. This is adjacent and hypotenuse. We're going to use cosine of 40 equals 8 over x. Now, did any of you guys notice a pattern of what's happened every time we had an x in the denominator? Where did it end up, and where did the cosine or sine or tangent end up? Let's look back. At the beginning, we had sine of 58 equals and an x on the bottom. What ended up happening? They ended up just switching places. Did that happen in the others? This one, the x was not in the denominator. Here, again, x in the denominator, they ended up switching places. X in the denominator, they ended up switching places. So a little shortcut to remember is if the x is in the denominator, the x and whatever your trig ratio is your trig function is going to switch places. So x equals 8 over cosine of 40. And that'll save you a little algebra. So x equals 8 divided by the cosine of 40. Again, we're rounding to one decimal place or to the nearest tenth, so it would be 10.4. Now we also need to find y. Again, we're going to use our adjacent side because it's given, and then we were looking at our opposite side because that's what we're looking for. So what uses opposite and adjacent? That's tangent of 40 equals opposite over adjacent. To get the 8 out of the denominator, we're going to multiply it on both sides. 8 times tangent of 40 equals y. So y equals 8 times the tangent of 40. We get 6.7. For your summary, compare and contrast finding side lengths using trig to finding angle measures using trig. That's all for today. I'll see you in class.